Hello, guys. I know you must have felt disheartened and demotivated seeing this hard problem and not being able to solve it on your own. And even other solution, you didn't understand much of it. It didn't make much sense to you. Well, this is a recently asked Google interview question. So it is tricky, but if you keep some basic steps in mind, and how to process such problems if you face it in an interview, I would tell that also at the end of the video, so please watch until the end. Trust me, after this video you'll code the solution on your own. I don't even have to hand feed you the code. I've broken down the problem into small manageable units which will make sense to think even during an interview setting. So you might not be able to solve the complete problem. The interviewer can give you hints, but at least you won't be blank. Because in such interviews, the most essential thing is for you to talk out your thought process. That's what matters in such interviews. I have given such interviews, so I know it very well. So even if you take hints from the interviewer while solving the question, if you show initiative and break the problem into many small steps, you'll definitely reach a conclusion by the time the interview ends, and interviewer would also be satisfied. So I've broken down the problem into small manageable units. The only condition I'm putting forth in front of you is that you have to watch the complete video and not midway, because you will miss many important points if you leave in midway, and then you won't be able to code it on your own too. So let's begin. This is the question where we are given -1 as a placeholder for no values. We have to insert values here, positive values, as x and y are given positive in the question. You can replace the -1s with either of x or y. So these two choices are there in front of us, and you have to place the positive values x and y strategically such that the maximum absolute difference is minimized in the question. So from this itself, minimize the maximum. One thing I deduced was that answer can be a range. That is why they're asking minimize the maximum. So that maximum can be many maximum absolute differences. So it would be a range. But out of those ranges, we need to minimize that maximum. So answer is a range. So out of that range, we want minimum. So this becomes our standard binary search or answer question. This is how I identify the pattern. And even if this exact language is not used by the interviewer, still you would be able to deduce this thing, because you know how to relate these words to the binary search on answer. So you don't need this exact wording. Whenever you find answer can be a range, out of that range we have to find the minimum or maximum. You can deduce easily that this problem is of binary search on answer. So I can deduce easily this thing even if I'm in an interview or setting. So at least you would be able to tell the approach to the interviewer. You'd get, suppose it is a pointed system, you'd get 2 marks here for identifying that this problem can be solved with binary search and answer. Depends on the interviewer, but still I'm giving 2 points for this. This is an example. So this is the nums array given to us with a placeholder -1 over the second index. So while in interview 2, I'm gonna take the suppose if they have given this example, I would take this example and dry run it to the steps that interviewer is asking. So we have to find the minimum of maximum absolute difference. So I would first find absolute difference of each and every pair. So I'm doing that, and out of that I would take out the maximum, which is 4 here. I chose 6 here. I can even choose a lesser number. I would give an example to the interviewer, like suppose I chose 4 as my replace value from -1, as there is only 1 minus 1 in this example, I can substitute either x or y, it doesn't matter, it would be just a single value. So instead of 6, I'm putting down 4 as my positive value to substitute. Suppose I put 4 here. Here the difference would be 2, then here it would be 4. And here, but here would be 2 again, would be 1. Again the answer is 4. So minimum is 4 again. But here it would be 6. So yeah, minimum is 4 here. So maximum would be 6 here. So minimum of maximum would be 6 here, and we have to minimize it. So this cannot be our answer because we're getting the maximum difference as 6 here, but in the previous one we were getting maximum difference as 4. So 6 would be our optimal approach. Even if you get confused in between, it's okay to process your thoughts in the interview too. I am simulating a real interview, so you get a brain freeze sometimes if you don't get what you're saying. So it's okay to take a 1 minute pause and then say it, like I did. So you showed an example to the interviewer. This he would consider like 1 or 2 points again, because you're showing that you understood the problem, and if you don't understand the problem, you can ask the interviewer for specific questions. He would readily answer you the questions, whatever you're asking. Suppose I got confused here while taking the difference out to be 6 or 4. You can ask him the question again, you can ask him the exact thing you have to find out again. So you will also get clarity of the question for you. Clarity of question. And this really helps you to again get time to think another, like whatever mental calculations you need to do. So now from this -1 you got a case itself. See here, suppose there can be many -1, suppose they are continuously, suppose they are one after the other, suppose they are alternative. Many cases can happen. So you deduce that from this example. From this example you thought of other edge cases which can happen during during the passing of the all test cases. So you can discuss those edge cases with the interviewer itself. But here we are solving the Leetcode problem, so we would go step by step. So base case would be we don't have any ones. 1, 3, 5, 7, 10. You can show this example during an interview too. Take out the differences. 1 and 3 we would get 2. 3 and 5 for each continuous pair we need to find their differences, and out of these differences like 2, 2, 2, 3, we have to find the maximum difference after we chose an x value or y value for -1, but here it doesn't have. So whatever the max absolute difference would be, that would be our answer, because we cannot alter the different absolute differences as we don't have -1 anywhere in this example. So this one case, if you discuss with the interviewer, he will give you 1 point for clarity, whatever. And this is the second case you're thinking of. Like suppose we have only one -1 value, like one position we can change. -1 here means this position we can change by substituting it by either x or y, which varies from 1 up to 10 raised to power 9. So suppose that absolute difference we get after substituting this -1 by a positive value be d, and that is the minimum absolute difference you can attain, minimum maximum absolute difference you can attain, and these are its border elements. So one thing you can observe in an interview setting too is that these adjacent elements directly affect the absolute difference value. So we have to choose an x or y in place of -1 such that we take into consideration the adjacent elements. Suppose the adjacent element here we choose x is a plus d or a minus d. So in an example it becomes 5, 10 and 5 minus d. Suppose if we are choosing 5 minus d. So here 5 minus d and 10 absolute difference can become greater because we are subtracting a smaller element from 10. So absolute difference can become greater here. That we don't want. We want to minimize it. So then we get this condition, like if we would have substituted 5 plus d, it would have been beneficial for both of them. Here 5 plus d is greater than 5, so the minimum max difference here could be considerably smaller. At least we have a chance here. In 5 minus d we have no chance. It would be smaller than the difference in this case. It would be greater than the difference in this case, and we don't want that. So we would choose this. That's what I wrote here. Minimum adjacent number of -1 should have plus d. Minimum out of these two. Why the minimum? Again the same question. Because here the max difference can be minimized if we choose the minimum adjacent number for our strategic placement substitution of -1. So either the -1 can be substituted by the minimum adjacent value plus d or maximum adjacent value minus d. Now from where did this come? We can take another case here itself. 10 minus d or 10 plus d. So 10 minus d would be less than 10. Less than 10 and phi difference would be less than, greater than 10 and phi difference. So here also 10 plus d, 10 minus d. Out of this we would choose this, because obvious reasons. We have to minimize this difference then. So these can be our 2x or y values possible. We would check for both of them and see which one gives us the minimum out of these two. This problem is all about, taking out cases and examining them properly. It's nothing more than that. So if you calmly see whatever cases you can make out of that -1, show the examples, deduce something out of it and go on, you can solve this problem easily. Every hard problem is like this. You have to break it down and go step by step. You definitely reach to an answer. Even if you take 1 or 2 hints in the process, it's okay. And without hints also you can deduce it if you break the problem into step by step processes. This is a Google interview, but it's interview problem, but it's not seeming like it, because you, yeah, I know you might have been thinking, no, it seems like it for us. It even seems like it for us. If for me, if I think like this is a Google problem, I won't be able to solve it. These past percentages, this much, that much. No. Once you get a problem, try to break it down into smaller pieces, and just go on with the flow. Don't think about anything else. So there can be more than 1 minus 1 in nums. Now if you handle the 1 minus 1 case, now we can handle the, now we would think of handling the case where there is more than 1 minus 1. This is the example we will choose here. You can choose any example, but for showing purposes I'm choosing this one. So here I have minus 1 in 2 positions, and the minus 1 is not consecutive, so you got another case from here. Minus 1 can be consecutive, the minus 1 cannot be consecutive. So you know what case to handle after this one. See how it's a domino process. Like if you write down one case, you get many other edge cases from that case itself. So suppose I choose these values in my example, 10 as m, 20 as n, 40 as this o, and p as 100. So this minus 1 has this 10 and 20 as its adjacent values. This minus 1 has 40 and 100 as its adjacent values. Now if only I concentrated on this one and chose this 40 plus d as my answer. Suppose I put 60 here, 20, here 40, but here that 60 would give me a 50, and here it would give me a 40. So I'm still not getting the minimum out of my maximum is 50. Now if I chose 20, I would get 10 here, 10 here, 20 here, and 180 here. So to choose this properly, I would choose 40 plus d or 40 minus d. But the minimum, if I want to minimize the maximum difference, I need to greedily take minimum of all mins and maximum of all max. Equivalent to global min of adjacent element of minus 1 of all adjacent element of minus 1. Because I want the minimum of all max differences, so I would choose minimum of all minimums to get my minimum adjacent, and plus d to that. That would make my global max difference as minimum. So here it's 10, here it's 100. So my minimum plus d would be x, which is 10 plus d and 100 minus d. These are the two cases possible. I would substitute these two cases and see in which one of these two I'm getting the minimum of minimum max value. That would be my answer. So I got two cases from here. Now case 2. These would be my x and y. Now case 2 is where the minimum of max comes from the non-adjacent, like the elements which are concrete, no negative, no changes you can make. So that case also we have to handle. Suppose we are getting Here by substituting something, like we chose max minimum adjacent plus d max adjacent minus d, and if we get that absolute difference as something less than what is from the non-negative concrete elements, that cannot be our answer, because this will actually exist in the array itself. You cannot change this. So again, this would be our bottleneck out of these two, max value out of these two. From 1000 and 100, 1000 is the max value, so that is the left of our binary search. No answer can be less than this answer, because we only can manipulate the non-concrete values. The concrete values would remain the same. So this would be our left answer range for binary search on answer. Now what should be the right? To get that out, right, what does this right actually denote in the binary search? It denotes the max possible answer. No answer can increase more than this, be more than this. This is the max possible answer. So to calculate the max possible, here what is the answer? Difference, absolute difference, minimum out of the max. We have to minimize the maximum difference. So max non-concrete value minus minimum non-concrete value in the whole array, that would be our right. Our answer would be bounded by these two conditions. You cannot have an absolute difference less greater than that. So max value minus min value. Suppose in this example your min value is 9, max value is 99. So R would be 90, because if I substitute the max value and min value inside the array in place of the negative values, somehow I would get this difference. And if in case these are not present, then also we would get 90 as our max difference. So one way you can think of fixing the right border is that suppose you don't have any positions where you can change the minimum of maximum difference. So that way, excluding them, this is the area. So max value minus min value would give us the right range. -1, you can add them. Suppose only one negative value was there in between here. And here I substituted 9. So here it would be 0 max difference. Here it would be 90 again. So minimum of max would again give us 90. So your answer range would always lie here. It's logical. Okay. Now let's move to the next part. We got the left and right range of our answer. Here our answer would lie. We would apply binary search on this answer space and then use a check function to check if this is even possible or not. Okay. and we have conditions on x and y too. So using that x and y, if it's even possible to attain these values. So our left was max absolute difference of concrete non-negative values, this, and our R was max concrete value minus min concrete value. Now we would implement the check function of binary search here. The check function has many just if else conditions because of the negative one's variability, because the negative one can have many cases, and that is what generates many cases in the check function, because we have to check if the -1 can be replaced by proper x or y value which minimizes the maximum difference. We saw 2-3 cases while discussing the initial level of the problem. Those cases will also be handled here, and more cases which we saw, like continuous one -1s or alternative -1s, or the array ends in -1. These cases, all this will be handled here in the check function. So I'm summarizing all the cases here. Suppose we substitute all the negative ones with all x, or all the negative ones by all y, wherever they be present. It doesn't matter. Condition 1. Condition 2. We are doing x and y mix. Now count of the negative ones is, if it's greater than 1, we have to also check this absolute x minus y is less than equal to d. This is the condition 2. For all x and all y, I will show you an example. 10 minus 1 minus 1 minus 1. This is, suppose the absolute difference is d. This is your previous value. This is the I which is at -1. So previous minus nums of I should be less than equals to d. This would be the case. And others are -1, so it doesn't matter. Either all would be replaced by x, all would be replaced by y, and we would take the minimum out of these max differences we get after substituting like this. Minimum of all x comma all y. That would be our answer, and if it is less than equal to d, we would return true from here and move the left pointer ahead, move the right pointer towards the left, because we need to find the minimum in our binary search template. This is only the check function. Here x y mixed, I'm gonna show you this now. Suppose it's a minus 1 minus 1 minus 1, and instead of this I'm substituting x, y, x. So this difference also I have to check, is less than, if it's less than equal to d. If it's not, then I would straight away return false from this condition. See, if both the conditions are false, return false. And if either one of these conditions is satisfied, we got a possible answer. So return true. It would think of a smaller absolute difference value from the LR range to check again using the check function if that is feasible. So cases of minus 1. See, 1 is no negative. This is the second 1. So basically we have to keep count of these negative ones in our check function itself. If the count is greater than 1, and here also if its count is greater than 1 and 1 border. Because why we are checking this specially, because we have the option of substituting minus ones here with x or y or both. So that is why the absolute of x minus y, here we get another condition to check, which I showed you here. This same condition, x and y mixed, count of negative ones is greater than 1, then we have to check this condition also. Here also same, 1 border, same case. So these 4 cases actually we have to handle in the check function. So for these 4 cases we would have the if else conditions. Check function calculation is the only tricky part in this problem. Only tricky part. If you stayed calm during the interview, went step by step, showing the proper examples, thinking of the edge cases from those examples, you would arrive here ultimately. It's not that, but the most important part is being calm in the interview. And even if you solve it on Leetcode, be calm. If you're not calm, you will definitely be not able to solve the problem. But if you're calm, you at least have 70 or 80% chance that you would solve the problem without even help, if you stay calm. So staying calm is very essential here. If you stayed calm, 80% of the battle you have already won. And congratulations for making it up to the end. Many people might have gone away midway and they would have lost the chance to take the benefit of all the information I was given. So you're already ahead of 99% of your peers. They got bored, they left, they thought they cannot do this problem. Don't give up. Remember folks, half knowledge is even worse than no knowledge at all. Remember it. Now you can easily code the problem, but still I have written the solution in C++, Java as well as Python. You can check my code link from the description below. And please like and subscribe to my channel. This really took a lot of time to record, to write down these notes for you, and giving and giving everything away for free. So please subscribe to my channel, like and comment what you thought of this video, or just comment something to boost the algorithm. This would really motivate me to bring out such detailed solutions each day. Thank you.